Okay, hello there viewers. Actually, this recording I'm making for my students, and I was thinking, hey, you might be able to benefit as well. Okay, this is a rough cut which I just make for my students, so have a look. All right, so let's start with the integration basics. Okay, we know that integration is a reverse process of differentiation. That's the most basics of all. Right? So if I give you something as simple, let's say x squared plus 5, and I want to differentiate it. So what happens is, firstly, we take the power 2, then we transfer to the front part, and then we minus 1. So we get ourselves something like 2x plus 1, 2x plus 0. Okay, because 5 differentiate, we got 0, constant. So remember the process, like I mentioned just now. Firstly, we transfer the power, in this case, differentiate become times, and then the power I minus 1, and the constant turn to 0. Right, so for integration, let's say x squared, the process a bit the other way around. So firstly, I plus the power first. 2 I plus 3. 2 I plus 1, I got 3. Right? And then the power, then only I transfer to down. Right? Sorry, some part accidentally erased. So the process similar but quite the other way around. Firstly, you plus the power first, and then only you power transfer. So I want you to memorize this way. There's a switch over there. You need to remember this basic, because as we progress, things are getting more and more complicated. You might get things mixed up. All right, so remember, firstly, there's a switch, you plus the power, then only you transfer. And remember this way, the transfer for integration is divide, while the transfer for differentiation is times. I want you to know the difference, because you might get confused, and I did get confused when I was a student. In fact, I only got these things clear when I was around 23 years old, so it took me a long time. Right, so let's go on. So you might ask yourself, hey, why plus c, sir? Well, remember, if I give you something like this, x squared plus 5, and I differentiate it, I got myself 2x. And if I were to integrate that one, okay, and remember, integration is a reverse process. So 2x, I got myself x squared, but I don't have my plus 5. So the plus c is the one that denote the plus 5. Okay, so that's why there's a plus c. What about if minus 5, sir? Then we still remain it as plus c. It's just the value of c is equals to negative 5. Right? Let's move on. Okay, now let's try differentiate exponent. Differentiating exponent is easy. So firstly, differentiate the power, you transfer in front, and the power remains the same. Right? Exponent power remains the same. It won't change for differentiation. So as I mentioned just now, differentiate power and transfer. Remember, transfer for differentiation is times. All right. So now we are applying these things as well. So applying the same things, you differentiate the power for integration, and then you transfer. Remember, transfer for integration is called as divide, and as the same as differentiation, the power remains the same. All right, as I mentioned just now, please remember this way. Transfer for differentiation is times, transfer for integration is divide. I myself still got confused of this when I was around 23 years old. Yes, that's the exact question. And I hope this will help you to memorize things, understand things better. Okay, so you won't mix them up, especially in exams. Right, now it's the basic tips. If you got yourself, let's say for differentiation, we start with the left part first. All right, so for this one here, if I were to differentiate that, I can split it into two parts. So firstly, I split it. So the idea is the same. Split if possible, then only you differentiate. It's easier to differentiate. You got yourself one. For the second one, all right, for the second one down here, I'm not saying that you can use power rule, but if you see it's power 2 where it's easy for you to expand, then expand. Right, so you got yourself into here, and then boo, you got that. It's easy as that. So the idea remains the same for integration. So split if possible. If you can split, you split it up. So we split it up into two parts. Boom, x plus 1, and then integrate that, it become easier. Okay, and expand if possible, if it's easy. Expand if easy. So you got something like this, expand it up and just integrate it. Boom, as easy as that. What do I mean by something not easy? Let's say to power of 3, to power of 5, and that's certainly not an easy things. All right, so we can go on now. But there is a situation where you don't need to plus c. This is where we call ourselves as a definite integral. It looks something like this, where there's a power 5. As you can see, there's a 5 and 2 over there. There's a limit of it. So if you see the 5 and 2, integrate x cube, we got ourselves as a x4 to the power of 4. No plus c and 5 over 2 as the limit there, and then we transfer it. Okay, and transfer I didn't do here, but I'm just trying to emphasize here, no plus c. If you put plus c in this situation, you will lose 1 marks, which is sad. Alright, so now let's move on. So this one here, I want you to see some pattern. For differentiation here, you can see the left side, everything just, the power just reduced by 1, as 3 becomes squared, 2 become 1, 1 becomes 0, and so on. And you can see that differentiate 1 equals 0, constant, differentiate of x negative 1, I got myself as a negative x minus 2. Now let's try integrate. The integration, the process are kind of the same over here. Okay, as so we keep on adding the power, 2 become 3, 1 become 2 become 3, 1 become 2, and so on. Okay, and 1 power 0 here becomes 1. Right, you got the idea. And what about if you go to the negative side? If we go for the negative 2 plus 1, negative 1, and still okay. Now what about if I ask you power of negative 1? Because if you minus 1 plus 1, you got 0, power 0 is 1, but it won't work that way. So what are we going to do? Well, let me ask you, remember that so what do we differentiate to get 1 over x, or x power of negative 1? Remember, differentiation and integration, they are a reverse process of each other. So what do we differentiate to get 1 over x? Is ln x. Differentiate ln x, we got ourselves 1 over x. So integrating 1 over x, we get ourselves as ln x plus c. Or in this case, integrating x power of negative 1, which is equals to 1 over x. We got ourselves as ln x plus c. Okay? Alright, this is something new for you. You haven't heard anything that we integrate, we got ln. We haven't learned yet that in the school days. So when do we integrate to get ln? Well, the formal definition is something like this, where integration of f prime x over fx, we got ourselves as ln fx plus c. Well, that's too much of a textbook and not really that applicable for layman people. So this is why I propose a Rodhi method, or Rodhi's method of memorizing it. So you got something like this, okay? Where if I differentiate the denominator, let's close that one first. If I differentiate the denominator, and I go, so this doesn't change. If I differentiate the denominator, computer doesn't want to follow. Okay, you get the idea. If I differentiate the denominator, and I got as the numerator, so this is where I applying ln. Differentiate deno, I got numer, so it become ln deno plus c. Okay. So I give you several examples here. So 1 over x, in this case, differentiating x, we got myself as 1. So you got same as numerator, so that's why you got ln x plus c. I give you a harder example, it's going to look something like this. X squared plus 5, if I differentiate the x squared plus 5, I get myself as a 2x up there. Since I get myself as 2x up there, so I got myself a ln x squared plus 5 plus c. Okay, so the ideas remain that way. If you understand the basic idea, you understand the basic pattern, you'll be pretty much fine. Okay, sorry, my pen is not working. All right, so let's move on. Oopsie. So this is some cool trick where there's a missing constant. I'll show it to you. Where in this case, where x over x squared plus 5, if you differentiate the denominator, x squared plus 5, you're going to get yourself as 2x. We got the x, but we don't have the 2, which is the case here. The 2 is the constant. So this is where I call the missing constant case. All right? So you can do this cool trick. Look here, look here. I can multiply outside by 2 over 2. Why am I doing it this way? Because you need to remember that 2 over 2 is equals to 1. So if I'm multiplying that, I do not change the equation. Things remains the same. Okay? Still the same. And now, these 2 up here, the 2 above, the numerator 2, I'm going to transfer it inside. I'm going to take it and I'm going to transfer it inside. So outside it becomes as 1. So now the inside becomes 2x. So if I differentiate the denominator, I get myself as a 2x. Okay. So now if I were to integrate it out, so since I differentiate the denominator, I got as a numerator. So it's a ln deno plus c. But there's a one little part where people keep on forgetting. There is this, the 1 over 2 outside. So do not forget it becomes 1 over 2 outside over here as well. Okay, ln 1 over 2 ln x squared plus 5 plus c. Okay, that's all for now, and this is a rough edit. I'm not sure whether I'll edit it down again. If you got the idea, I think it's going to be the same. Okay, so yeah, Please comment, share, like, and subscribe. If you have any questions, comment down below. Subscribe to this channel, please. And yes, thank you for watching. All the best for your exams. Bye.